Hello and welcome to YourPedia. My name is Aman Sharma and I am your mentor for CSE at YourPedia. So at YourPedia we have started a batch for data science, the GATE paper that has been recently introduced. In that batch there will be two separate batches for non CSE students and CSE students. So we will be covering the topics that are mentioned in the exam syllabus. We will be covering them according to the non CS students also and CS students also. So the batch is starting from today. So let's get on with the video. So today's video is about the basic differences between AI, ML and data science. So we will not be diving deep into the artificial intelligence or machine learning or data science, but we will see what are the basic differences between them, how they are related to each other. So this topic is basically regarding the new GATE paper that has been launched in the data science field, and the syllabus of that topic of that paper is will mostly consist of AI and machine learning, though there will be some other core subjects also such as DBMS, maths and your algorithms, but it will mainly focus on the AI, ML and data science part. So today we'll see what are the basic differences between AI, ML and data science. So first we will see AI. Now AI is artificial intelligence. Now what is the goal of artificial intelligence? Now the goal of artificial intelligence is to mimic human being, and it will create a system that can function intelligently and independently. So AI will be designed in such a way that you will not realize that you are talking to a machine or you are interacting with a machine. So this is the main goal of AI. So what is the main goal? To mimic human behavior, that can function intelligently and what? And independently. Now this is the main goal of AI. Now we will when we will go deep into AI, we will see that there are multiple types of AI. That there are weak AI, strong AI. Now there are some more types of AI also. Now those types will vary according to the power of AI. Now if some AI is just focused on one part of the problem, then that will be categorized under weak AI, and after that if it is doing multitasking and if it is handling multiple problems, then it will be strong AI. If it is interacting with the human in a very good way, then it will be categorized into another type of AI. And there are also some AIs which are just theoretical, but we are defining them on the expectations that we will be having from that AI. So this is what AI is. It is just to mimic the human behavior, so you will not feel that you are interacting with the machine. Now as we see, I have been saying that it should function intelligently. Now what do we mean by intelligent behavior? So what do we mean by intelligent behavior? So what is intelligent behavior? So first is problem solving. So our machine should be able to find a solution to some problem or to the complex problems or issues that has been given to the machine. So it should be able to process the solution to a complex issue or complex problem. Now it can use various methods or various algorithms in order to achieve that solution, but we will not go into that. But it should be the main task or main functionality if we want the machine to be simulating a intelligent behavior. Next is reasoning. What do we mean by reasoning is, reasoning is act of thinking something in a logical way. So reasoning is act of thinking something in a logical way. So if the machine has been given a choice, it should be able to think in a logical way, and out of those choices it should be able to select the best choice that is necessary for the case. Just like a human being, that you will measure the pros and cons of the system, and then by seeing the pros and cons you will make a choice whether you want to buy this or whether you want to do this and do that. So it should be able to do the reasoning. It should be able to think in a logical way. Now next is process of making. So process of making important decisions. So it should be able to make important decisions by handling the pros and cons. So it also comes under reasoning. Now reasoning is just act of thinking something logically. Now this comes under the category of making that choice. So this category is called decision making. So the machine should be able to first see what the problem is, and then rectify that problem with some solution. So it should be able to find a solution for the complex problem. Next is reasoning, act of thinking something in a logical way. So it should be able to see the pros and cons of all the algorithms or all the problems that has been given to the machine. Then the final is process of making a important decision, which is known as decision making. Now if we see what ML is, machine learning, if we move toward machine learning, now machine learning is what? We feed the data to the machine. In machine learning, what we will do? We will feed the data to the machine. Now that data, our machine will be trained on that data. Train the machine on the given data, and we will construct a model. On that model we can give inputs to the machine, and depending on the inputs and the model, the machine will give us some output. So machine, what we will do, the data that we have given to the machine, so machine will extract important features from the data, and depending on those features, it will create a model. It will train on that data, it will create a model, and when the model is ready, we will give it some input data and it will give us some output of that data. Now in order to do all this, we will use machine learning algorithms. There are multiple machine learning algorithms that are present and that are being made nowadays. So the machine will use ML algorithms to extract data features. There are multiple machine learning models or algorithms, ML algorithms present. Some of the name of the algorithms are like you can say regression is a machine learning model. Regression. Now regression is also of different types. There can be logistic regression. Then we have polynomial regression. After that we have KNN, K nearest neighbor algorithm. Then we have forest tree. Then we have Bayesian model, which works on the Bayes theorem that we study in the probability. Then we have SVM machines and so on. So these are some of the models that we will use in order to on these models, the model will be trained through the data, and then we will test the data by giving it some inputs and checking whether the output is correct or not. So this is how machine learning algorithm works. Now let's see an example also. Let's say that you have the data. The data is, you have, let's say, this is the size of the plot, this is the price. Let's say that you have 10 acres of land, and for 10 acres the price is 10,000. You have 20 acres of land, the price is 20,000. 30 acres of land, the price is 30,000. It is asking what will be the price of 40 acres of land or 50 acres of land. Now here there are only two variables, size and price. Now it will see that what is the relation between the size and the price. Now whatever the size of the plot is, you just multiply it with 1000 and you get the price of the plot. Now it will create a graph for it. Here we have size 10, 20, 30, 40, 50, and here we have the prices 10,000, 20k, 30k, 40k and 50k. Now it will draw the points that for 10 we have here, for 20 we have here, 30 we have here, and it will draw a line that this is the linear pattern that has been recognized by this data. Now when it has trained the model, it will see that what will be the price of 40 acres of land, and it will see that for 40 acres of land 40k is the price, and for 50 acres of land 50,000 is the price. So this is how it will match the data. It will first create a model that will fit that data. So when the data fits, it will create a chart or it will make a pattern, and depending on that pattern it will predict the output, whether then after that we will see whether that output is correct or not, and this will define the accuracy of the model. Now let's say if in this data there were some other factors also, like let's say we take the data, we have first, let's say, size. Now size is 10 acres. After that let's say swimming pool. Now swimming pool is there in the house, so let's say a swimming pool is not there in the house, and parking is also not there in the house, and it is not fully furnished. So the price is 10,000. Now when I take the same flat or house with 10 acre of land, and I say that swimming pool is there but parking and fully furnished not, so it rises to 15,000. And if I take the same flat with swimming pool and parking and no this fully furnishing, this is the rate. And for some other plot we have 40 acres, we have this, we don't have this, and there will be so much this type of data. Now there are 4 factors that are influencing the price of the plot. Now in this case you cannot use the logistic regression, because in that there were 2 factors, one was directly dependent on the other. In this, depending on the 4 factors, you are finding the price. Now when you do this manually, you will not be able to do it, because if you see these 4 factors, if you have 10 acres of plot, you have 3 factorial possibilities with 10 acre of land. So there will be 6 entries, 6 multiple entries for 10 acre, then there will be 6 entries for 20, then 30, then 40, then 50, and then after analyzing all those possibilities, you will create a pattern. So the machine will create that pattern, and you will use that pattern in after that you will fill that. Let's say the size is 60 acres and there is no swimming pool, there is parking, it is not fully furnished, then the machine will give you the output that this should be the predicted price of the house. Now in this case we can use polynomial regression, which will instead of logical regression, which will in polynomial regression we can accommodate multiple factors in order to create the pattern. Now we can also use some other this your machine learning algorithm. Now what we will do, we will train the model on this data set by using multiple machine learning algorithms, and then we will see, we will have the actual then when we will test the data, let's say that the test is that for 60 acres of land, and there is no swimming pool and there is no parking but fully furnished. Now in that case, 60 acres of land, in that 60 acres of land, what happens is, you know that price should be 1 lakh, but our model, this our polynomial regression is saying 80,000, and some other SVM model is saying 90,000, some other KNN model is saying 1 lakh. So you will see multiple test entries, and you will compare their outputs with the predicted outputs of the model, and you will see which model is performing with the best accuracy, and then you will see which model to use in that case. So this is how we will use machine learning algorithms in order to get the expected outputs. Now after that, let's see what is now we will see the difference between machine learning and data science. Now let's see what is, now we have already seen AI and ML. Let's see what data science is. Now data science is what? Now in machine learning, you feed the data to the machine. Now where does that data come from? You cannot just pick up some data and directly feed it to the memory. So that is where data science comes in. What is the main purpose of data science? So first let's take an example. Data recommendation. You open Amazon and let's say you buy a phone. Now when you buy a phone, when you will be checking out, you will get a recommendation that are you interested in buying a phone cover? Now where that recommendation came from? Now that recommendation came because of data science. Why? Because there is multiple type of data present on Amazon. Now what they will do, they will segregate that data, and they will find that what is the data of the customers that have bought a phone. Now in that data, what they will do, they will see what is the item that they are most buying while buying the phone, mobile phone. Now when the data, when they will analyze the data, they will see that let's, for example, let's say 10 people bought phones. Out of those 10 people, 8 people bought covers, 7 people bought headphones, and there was one person who let's say bought chips. Now the data, when you analyze the data, you will see that there is as there is very less resemblance between phone and chips. That is why only one person was there who was buying chips with when they were buying phone. So it will see that 8 people have bought covers and 7 people have bought headphones. So when you buy a phone, it will extract the features from the data, though the system will extract the features from the data, and it will see that whenever someone is buying a phone, you should recommend covers and headphones also to that person. So this is how data recommendation works, and this data recommendation is possible due to data science, because we are extracting the features, we are we are taking the raw data and we are making that data into something useful. So what data science is, if we want to write a definition, finding the important information from a large set of data. Now that data can be structured and that data can also be unstructured. Structured means that data will be labeled, that this is the data of customers who bought phone, or there will be labels to it. Unstructured data will be unlabeled. labeled. So this is what data science is, finding the important information from a large set of data. Now after that information will be used for data recommendation. Like it will be used for multiple purposes, but data recommendation is one of the example of, or one of the uses of data science. Now what are the basic states from which our data science model goes through? So first is understanding the business. Again we will take the example of recommendation. So first you should know that where you are segregating the data. Like you should know the business. Like if someone is ordering a phone, you should recommend it a cover. So you will only use the data, or only use the data of the customers who are interested in buying a phone. Next is data gathering. Now you have analyzed that what type of data you will be required to gather. After that, what type of data, after you have seen that what type of data you need to gather, you need to see what will be the labels that you will be assigning to that data in order to segregate that data in a much better way. So the second step is, first after understanding the model, the second step will be data gathering. You will be gathering the data. Third step will be data preparation. Data preparation means data cleaning. So you don't need any type of data, you only need the data that is required to you or that is useful to you. Now in the data that you will be extracting, it will have these three features. Let's say a small data set. In that data set you will be requiring this, because phone covers 8 people have bought, you will be requiring this, but this is not of your use. So that is called data cleaning. You will be cleaning the data and making it in a form that is most suitable or more will be more useful for you. Now after that, last step will be data modeling. You will be applying machine learning models to that data in order to extract the basic and better features, and after that you will be using those models in order to make those recommendations, in order to make predictions, or whatever you want to do with that data. Now if we see what type of machine learning models we have in relation to the type of data. So first we have supervised learning. So machine learning will have three types of learnings. Supervised learning, first of all. In supervised learning, you will be giving or feeding the machine the data which is labeled, or you can say which is structured. So what you will do, for example, let's take an example for this. Let's say you have 3 cars, the images of 3 cars, and those are labeled as car 1, car 2 and car 3, and you have 3 bikes, bike 1, bike 2 and bike 3, and you have 3 trucks, truck 1, truck 2, truck 3. Now this will be fed to the machine and it will have labels that this type of thing is car, this type of thing is bike, and this type of thing is a truck. Now when you, at the time of testing, when you, let's say, input this thing, it will see that it is matching with this type of data. So it will predict that it is a truck. So this is what supervised learning is. Now when you move on towards the unsupervised learning, so what will happen in unsupervised learning, that the data will not be labeled. Now the main task of supervised learning is that when after creating a model, when you will give any input to it, it will predict the output. So prediction is done, or you will get an output from the supervised learning. But in unsupervised learning, it is used to find the patterns or hidden features in the data. So in unsupervised learning, we will be feeding what? we will be feeding unlabeled data to the machine. So what do we mean by unlabeled data? So you will be just feeding these diagrams. Now the machine will train the model and it will segregate these into 3 different parts by extracting its features. Now after that, when you input this, it will say that it belongs to this category. So it extracts the feature of car, bikes and trucks and it segregates it, and then it will let you know that whatever you are inputting, whether it belongs to this dataset or this dataset or this dataset. So basically what we are doing is feature extraction, and in unsupervised what we were doing, we were training the model in order to make the prediction. So when the model was trained on the training data, after that a testing data will be put on the model, and whatever the output is predicted, we will match that output with the actual data, and we will see how much accurately our model was behaving with that data, and depending on that we will select whether we will use this model for that type of data or not. After that, third category is reinforcement learning. So reinforcement learning is basically behavior learning. So what you will do, so there is in, let's say, action that your machine performs. Now based on that action there will be a reward factor. Now if that action is good, you will reward it, and if that action is not good, you will not reward the machine. And after that, when it again sees, when it again performs the action, it will see that previously when I performed the action in that way, I was rewarded. When I didn't perform the action in that way, I was not rewarded. So it will learn from its behavior and it will then improve based on this reward system. The most basic example of this reinforced learning is, let's say, chess game engines. In those, what we do, the machine will learn by playing chess, and as the time progresses, it will increase the accuracy of the machine, and it will learn new patterns, and it will evolve to be a better chess engine than it was at the starting of the game. So these are three types of machine learning. Three types of machine learning. Now if you see, what are the relation, what is the common ground between AI, ML and data science? So let's draw a Venn diagram. So let's say this is data science, this is ML, and this red is AI. Now whatever the models that we are using in machine learning, let's say KNN model or your regression model or your Bayesian model. Now all these models will be used by machine learning also, these models will be used by AI also, these models will be used by data science also. Now there are some fields in the AI which will not require machine learning or even data science, such as linguistics or robotics. These are independent types of AI in which AI is used. So machine learning we will not be using in that field, and data science will also not be used in that field. Similarly, there are also some data science methods that does not come under the category of AI and machine learning, such as your process mining, your visualizations, data cleaning. So this is a Venn diagram which will tell you that how AI, ML and data science are related. So there are multiple things that we are doing nowadays that will come under machine learning, and they will use the data that will be used by machine learning will be cleaned by the your data analysts, and after that those machine learning models will be used to implement artificial intelligent programs. Now, so that is all for this lecture. So if you have any doubts, you can post it in our in the comment section, and I will surely try to help you out. So we have started a batch for this GATE paper of data science. In that we will be covering both the theoretical and your numerical aspects of the exam. Whether it is linked to the core subjects of the exam, that is algorithm and data structure, core computer science subjects, or whether it is related to ML, AI, or the mathematics, that the advanced mathematics that will be used in the machine learning and AI subjects. So I hope you like the video. So keep watching and keep sharing. Thank you.